The following program is brought to you by Caltech.
Good morning. Such a great response. And so early in the morning. My goodness. So, good morning. I'm Heather Dean. I am currently the president of the Caltech Alumni Association, and welcome to Caltech's 16th Annual Alumni College. I am very excited about this. As a scientist, as well as a Caltech alum, I'm a neuroscientist who is currently a policy fellow, science and technology policy fellow with the American Association for the Advancement of Science, working in the Washington, D.C. area at the National Science Foundation. And I know how important this subject is. So, as alumni and guests, we are part of an amazing community. And this event is designed to strengthen our community by bringing together and reconnecting with each other, faculty and the Institute and alumni. Alumni College is also presented to give you expert information about one topic in which the university has focused its attention and resources. And this year, we'll hear about research in translational medicine. And this area has become a focal point in scientific interest to the general public, as well as to an increasing number of students, staff, and faculty on campus, and for very good reason. The National Institute of Health recently signaled its strong interest in this with the newest institute. And certainly, in a time of diminishing or at least flat budgets in federal research grants, it's highly important. The public makes it very clear that they want to see results and translational research. And I should say, I'm a basic research scientist, and I will certainly advocate for the importance of basic research. But this, in medicine, it's very important that we translate that into things that will help the public. And as I mentioned, with diminishing budgets, the public is more and more interested in seeing what the results are of the research. So today we'll learn how Caltech excels in medicine without the partnership of a medical school. So many other places I've been, I went to Duke University for my PhD in neurobiology and New York University for my postdoc. At those places we have the benefit of a partnership with medical school, and Caltech does not. And Caltech tends to focus more on the basic research, and as I mentioned, for good reason. But it's amazing that we do as much as we do in translational research. So to explain more about the extraordinary work from campus, I'm happy to introduce our first speaker. He received his bachelor's degree in biochemistry from Cornell University and his PhD in biochemistry from the University of California, Berkeley. He was a Lucille P. Markey Charitable Trust postdoctoral scholar at the University of California, San Francisco. His honors include a Searle Scholar Award, a Beckman Young Investigator Award, a Burroughs Wellcome Fund New Investigator Award in the Basic Pharmacological Sciences, the American Society for Cell Biology Pro-Mega Early Career Life Scientist of the Year Award for 1999, and appointment as a Fellow of the American Association for the Advancement of Science, AAAS. In 2011, he was elected to the American Academy for Arts and Sciences. His Caltech lab investigates the cellular machinery that mediates protein degradation by the ubiquitin proteasome system, and how this machinery regulates cell division. In addition to his academic work, he co-founded Proteolix in 2003 with Dr. Craig Cruz, Dr. Susan Molyneux, and Dr. Phil Whitcomb. Proteolix initiated development of Kyprolis, thank you. Kyprolis, I should have checked that. And was acquired by ONCS in 2009. In 2011, he also co-founded Cleve Biosciences with Drs. Seth Cohen, Frank Parlati, and Peter Thompson. So, ladies and gentlemen, I'm happy to introduce Professor of Biology, investigator at the Howard Hughes Medical Institute, and Executive Officer for Molecular Biology, Ray DeShalis. I should check that too. So sorry. Thank you. Just know you as Ray.
Hello and welcome. It's great to see so many people here on a day with such beautiful weather. So I'm actually not a speaker today. I'm just warming up for Mark Davis, who's going to talk to you. But what I would like to do, without taking too much time away from Mark, is I'd like to just emphasize a couple of things about Caltech and what you'll hear today. The first is that, the two things I'd like to emphasize are, number one, the importance of basic research to the mission of Caltech and how that underlies what we do in translational medicine. And number two, the extraordinary quality of the people at this institution, the faculty, the students, the postdocs, that makes this institution what it is. Now, the success of Caltech in translational medicine, you'll hear about that today, really has its roots in the extraordinary basic research that is carried out at Caltech every day. That is the wellspring from which the key discoveries that lead to translation into the marketplace arise. And it's this commitment to fundamental research that keeps Caltech researchers at the cutting edge of their disciplines. And importantly, because of this commitment to basic research, when Caltech researchers translate those findings, they're not merely incremental. They tend to be paradigm shifting because they're making new discoveries that are pushing the boundaries of what we know about nature. And when those new discoveries are translated into products, those products are not just, the next slightly better widget. They're often an entirely new widget that was not conceived of before and not reduced to practice before. And so I think it's essential that Caltech's fundamental research commitment is an essential component of why this institution is so extraordinarily successful in translating discoveries into the marketplace, not just in translational medicine, but in all areas of research at Caltech. Now, the second point that I'd like to emphasize, actually, before I move on from that, I'd also like to make the point, I've been thinking recently, I don't actually like this term translational medicine. Number one, we don't have medical school. And number two, translational medicine has become a very fashionable term. And it's a term that describes what happens at many other institutions that do have medical schools. And I think what happens here is actually fundamentally different from that. And so, I'll just throw the idea out there, but I like the term of what we do here I refer to as future medicine, right? We are doing things here that will have a significant impact on how medicine is delivered to people in the future. So today's about future medicine from my point of view. Now, the second point I'd like to emphasize is how impressive my colleagues here are. Which is, for me, it's been an extraordinary driver for my own career. I've been here nearly 20 years, and every day when I come into work here, I feel humbled by the people around me. They're just extraordinary. They've made extraordinary impacts on science, and some have even made extraordinary impacts on society. And it has inspired me personally to dream big dreams and reach much further than I would have otherwise been inclined to do, just by the example set by some of the colleagues that are around me. And the end product of that is that Caltech, despite its very, very small size relative to most major research universities, has had an enormous impact on the scientific enterprise, and also has an outsized impact commercially in terms of translating its technologies into the marketplace. And this, along with the fantastic students, graduate students, undergraduates, as well as the terrific postdocs that we're able to recruit to this campus, has been a major factor in ensconcing Caltech as number one over the past several years in the world university rankings, which it's amazing to think, how small Caltech is, and yet we've been number one in that list. And it's really a tribute to the amazing quality of the people here and their commitment to fundamental research and taking the knowledge of that fundamental research and moving it into the marketplace. Now, one example, I'll just stop with one example I think that really illustrates this, and that's the keynote speaker today, Bob Grubbs. So Bob Grubbs has been at Caltech, considerably longer than I have. And most of his career, he's spent trying to understand and develop catalysts that enable the formation of carbon-carbon bonds with a higher efficiency and at lower temperature than would otherwise be required, and using less nasty chemicals to catalyze the reaction. So that was really fundamental research that he engaged in for decades. Now, eventually he figured out the catalyst to do that, which led to a nice December trip to Stockholm. But then upon realizing this discovery of these catalysts, it became immediately apparent that forming carbon-carbon bonds is extremely useful for making all sorts of materials. And he founded a company that's just on San Gabriel Boulevard, like about 2 miles east of here, Materia. And Materia has been involved in licensing that technology to companies in many different industries, ranging from making stronger and lighter sporting equipment to making artificial lenses that you can put in the eyes of human beings. And there's now, I think, about 3,000 people. I heard him speak the other day, 3,000 people in Europe that have these artificial lenses. And it's still in testing. So as it's perfected and further commercialized, this is likely to have a much bigger impact on helping to restore vision to people who have suffered damage to their lenses. And I think that's a beautiful example of taking fundamental research that's been transformative in understanding an important problem in chemistry and then translating that into the marketplace to generate products that benefit human health. That, to me, is future medicine. Now, I feel I've already taken too much time away from the speakers, so I will cut my remarks short here and give the platform back to Heather. And thank you, and I hope you have a great day.